You must have heard about MCP, a new protocol for LLM models. But have you heard about A2A? It is also a protocol for LLM models sketched by Google engineers. In this video, we will go through each of these two protocols, understand their differences, and at last conclude that it is not A2A versus MCP. Rather, it is A2A and MCP. We will have a demo included as well at last. Let me first start with MCP protocol and its definition, standards, and examples. It's a protocol currently in boom and it's sketched by the engineers at Anthropic. Let us visit the official docs. So, by definition, MCP is an open protocol that standardizes how applications provide context to LLMs. Think of MCP like a USB-C port for AI application, just as USB-C provides a standardized way to connect your device to various peripherals and accessories. MCP provides a standard way to connect AI model, different data sources and tools. Let's keep this line in mind that MCP is a way to connect AI models to different data sources and tools. Okay, let's get back to the presentation. So what MCP is in very simple terms? The full form of MCP is Model Context Protocol. So here protocol means a set of rules which are predefined and communicating servers as well as client follows these rules. In reference to LLM, if I explain, it means that if I design a server using these set of rules which are defined in Model Context Protocol and use any framework like Django, Node.js, Fast API, anything. But the rules are followed that are defined by the MCP. So I can connect any of the client that actually supports MCP to these servers. So like I have to design the server only once, and then this server can connect to any of the client that for that supports MCP protocol. Then that client can fetch the data from the DB as required, or can call any tools that are defined in my route. Let's take a simple example to understand about MCP more in more details. So what I'm designing is an LLM, a personalized LLM actually. So if I'm designing a personalized LLM, it should know about me. So what I'm doing is, firstly I have designed a MCP server, and this MCP server contains some of the routes. Like it contains a route for my location, my profile, my favorite movies, and a tool for internet search. So now, since this is an MCP server, it follows all the rules and rules set by the MCP protocol. So let's take an example where I ask the LLM that suggest the movies I should watch today. And also, this LLM also is a it supports MCP. So it could be like Claude Desktop, or in future ChatGPT Desktop will also support MCP. So client should support MCP. That is what I am saying. So I asked it a question. He suggests me movies I should watch today. So it sees that all the routes that are available to it. So the most optimal route that it should follow is that it should get all the favorite movies that I like, and according to that, suggest me a movie that I should watch today. So it goes to slash my favorite movies, gets all the movies I like, and then suggests me a movie. Now, other example could be ki suggest me some of the best non-vegan restaurant that I can go today, yeah, at my location. So in that case, it first fetches what is my location through this slash my location route, and once it has this location, now it can use slash internet search tool and route also to get a search to make a search and get the best non-vegan restaurant in that location. This is how we can design and also once this MCP server is designed, we can use it with any of the client that is supported. I'm repeating it again and again because this is nothing new that we have that we were not able to do previously. We like that it is just a tool calling. We can do it without MCP. But the main benefit here is that we can use once the server is defined, we can use the same server without changing any code to any client that supports MCP. So that is the main benefit here. Let me show you some of the example of MCP servers. Uh, Here are some of the examples, and you can also see how popular it is, like Google Drive, GitHub, Google Maps, and even Spotify have made an MCP server to control their internal APIs via an LLM client. So one thing, like, I am again and again saying client, not an LLM. Like, I cannot say that Llama 4 supports MCP, whereas Llama 3 doesn't support MCP. This is an incorrect statement. Since internally it is just tool calling, but it is the client's responsibility to communicate properly with the server and then give that context to the LLM in a way that it supports. That's why again and again I'm saying that it can it can connect to any of the supported client. Let me now move to the A2A. So this is the official A2A site. As you know that A2A is sketched by the Google engineers. Let me show you what the definition of A2A is. So according to Google, it is the standardized way how agents communicate to each other. So it is also an open protocol, and it focuses on how one agent can communicate to other agent back and forth. Like MCP was key how like agent can interact with tools as well as data sources. But A2A is about communicating with from one agent to another, and from that agent back to the first agent. It is a back and forth communication actually. So similar to MCP, A2A is also a set of rules that, when followed, allow client connect and communicate to any A2A server. Let's take a example scenario that will make the differentiation between A2 and MCP more clear. So this is an auto repair shop, and consider an user come to this auto repair shop and he says ki my car is making rattling sound. Please fix it. Okay. Now the workers there, what they will first do is that they will put the car in that platform, and then they will raise it by a certain amount so that they can check backside of it. So when they raise the platform, that is a tool call. So that comes under MCP. But now, what if that rattling sound, that is something that is coming because of some scenario that they haven't faced before. So they will ask their supervisor about what is happening. So now the worker is communicating from one person to another. So that is an A2A protocol. So the communication is between one agent to another. That is a A2A protocol. Let's now take a simple application example. So this is a real application example that we are going to uh, build hypothetically. So let me tell the objective of this application. So we want to run command line like operating systems like Mac, Linux, Windows. So it is not key simple user will say run ls command, but it is key user says delete a file located in desktop, delete a readme file readme.txt located in my desktop on my Windows system. So the LLM can figure out that it needs to run cd desktop and then rn readme.txt for Linux, or delete readme.txt for Windows. So the application is something like this. Let me tell the component of these application. So there is this A2A client. This is a front end for user. Behind it, it contains an LLM which acts as a host, and also it supports the A2A protocol, so it can connect to any A2A server. Now we have three A2A servers. Mac A2A server, which contains an LLM fine-tuned for Mac commands. Linux A2A server, which contains an LLM fine-tuned for Linux command. Then an Windows A2A server containing an LLM fine-tuned for Windows command. Uh, The A2A protocol also has a task uh, object. So this task object actually, whenever there is a handover uh, by this host to any A2A server, then it creates a task. We will learn more about this task when we'll take a flow example. So let's take that. So the scenario is key user are delete a readme.txt file located in my desktop on my Windows system. So this goes to this host LLM, and host LLM uh, has already discovered that these are the servers that are connected with me. So now the host LLM hand over these tasks to Windows A2A server. So for doing that, it first create a task, and the status of this task will be set to submitted, and Windows A2A server will receive a query that delete readme.txt located in desktop. Now the LLM here, the fine-tuned LLM for Windows, will figure out the command. The command will be cd desktop then delete readme.txt, and it will see that in the MCP server there is a slash execute route. So it will call this execute route and this execute route will run the command in terminal and return the output to Windows A2A server. The Windows A2A server will mark the task as completed and return the output to the client. The host here then communicate this to the user that your file is successfully deleted and the task is now completed. Okay, now let's take a interesting and complex scenario. The user this time asks, delete a file located on my Mac system. The host again sees that these are the A2A server connected to it. So since it is a Mac server, so it hand over this task to Mac A2A server. Again, a new task is created with a new ID and the status is marked as submitted. Now the Mac LLM will see the query that it receives will be delete a file. It doesn't contain any file name or location. It only contains delete a file since that is what the user asks. So it will create the status of this task as input required and will send an input to the host that what file do you want to delete, and the status will be marked as input required. So the task here is not completed. So the host will read the status is input required and the input is what file you want to delete. This input is raised by this Mac A2A server. So the host will now communicate it to the user what file do you want to delete in your Mac system. The user will say, I want to delete readme.txt located in my desktop. Now the host will again communicate it to the Mac A2A server only. The query is delete readme.txt located in desktop. Now Mac A2A server will create the command that cd desktop and remove rm readme.txt. This will be sent to the slash execute route. This will execute in a terminal, give the output to the Mac A2A server. Then Mac A2A server this time will mark this as completed finally, since the task is now completed. This will communicate it to the host. Now host will say to the user that your task is completed. So this is how the A2A actually works. And to make a complex application, you cannot go with only one that I'm going with MCP since uh, MCP doesn't inherently support that you can communicate between two agents back and forth. You cannot create something like input required like it is present in A2A. So to make a more complex application, you have to consider both of these protocols actually. There are other features also present in A2A protocol like push notification, which is kind of webhooks, and also there is an authentication layer present in A2A. So it is like you not any server can connect to this Windows A2A server. Instead, you have to give the authentication in the headers and then you can connect to this A2A server. So we'll not be getting into those things that you can learn more from the documentation. But what we are going to build is a subset of this application. So our application will only contain this component, that is the A2A client and Linux A2A server and MCP server connected to this Linux A2A server. We can replicate this to create Windows, Mac server as well. But for now, only this Linux A2A server and the MCP server plus a client. So we'll create this application. I will also host this code on GitHub, so you can modify it and create the Windows Mac server as well. So first, let's create the client, this component. Okay, so client mostly contains the front-end logic. So this front-end is actually the one that is given in the Google's A2A repository, and I am directly using it with some modifications. Uh, but the front-end mostly contains the this only mostly contains that UI logic, so I'm not showing that. But let's go to the host agent code. This one is important. Let me show you the prompt that it is receiving. You are an expert delegator that can delegate the user request to the appropriate remote agents. You can use the list remote agent to list the available remote agents to you that you can delegate the task. Okay. And for actionable task, you can use create task. So as we have seen in our example, that for delegating the task, it first creates the task status to submit it, and then the task goes to the particular A2A server. So it is that case, first create the task, and also it can use this check pending status to actually ask the user that the input is required for this particular task. Uh, Let me show you the create agent part. So I am using the GPT-4o, and the tools that are present in this agent is list remote agents. So list remote agent actually list all the A2A servers that are connected to this client, and then this will give the information. So what this information contains, we will see when we will design an A2A server. And then this is the send task command. Send task command in this, what happens ki it first create a unique a task with a unique ID, and then send the query to the particular A2A server. Okay, so now let's design an A2A server. So our A2A server starts with this mainnet file, and this is the server that is defined. So in this, there is this agent card, and agent card actually contains the description. So this description is what I was talking about. Gets in this list remote agent function. So like for our Linux agent, it will be the name is the Linux agent. Description is helps with running command from the simple English query. Then it also defines some of the input and output that is supported. So this is the text, plain text. Otherwise, it could be those JSON and video and audio. Then there is this capability. Capability is key whether the streaming is supported or not, push notification is supported or not. Then for the skills, we for this particular server, we only have one skill, that is to run the Linux command. This is the skill, and the description is same. Then we have this one example. We can have two, three examples here. That when this skill should be called or executed. This is the example, one of the examples that display all the files on my desktop. So this is how our A2A server is defined. Let me now show you the agent that is present in this particular A2A server. This agent is actually invoked here. You can see in the task manager. Task manager actually manages the task object like updating the status, creating the new task, canceling the task, etc. etc. So here is our Linux agent. This is the prompt of our Linux agent that you are a specialized assistant for executing Linux command for simple English user query. Your sole purpose is to use the given tools and run the appropriate command and display the output. Another prompt just to make it more constrained. We also have a response format for our LLM. So this enforces that this is the response that is required by the LLM. So it contains the status. Status is key input required, completed, or error. And the message that is given by the LLM to the host. Okay, and then this will go through this later. The MCP part when we create the MCP server. The model here is again GPT-4o. We obviously we are not using any fine-tuned Linux command model. That was just an example. So yeah, let's design the MCP server. Here is our small cute MCP server. Since the defining MCP server is very easy, so that's why it is currently in very trending format. Okay, so the name is the Linux. Now in this we have one tool that is to execute Linux command. This is actually very dangerous. I'm just running the any command that is given by the LLMs. But yeah, okay. So it just takes the command uh, which is given by the LLM and run it, then displays the returns the output. So this is just a simple MCP server. The transport is SSE, so that means the server will be created. But how this MCP server is integrated to our A2A server, let's see that. So this is our agent that is present in the A2A server. We have already seen this, but this is, yeah, this part. This is the part where we are creating a context manager and connecting to the MCP server. We are defining this all the routes that are present in this MCP server in the tools section of the agent only. It is MCP, the routes of the MCP server are not something special. They are defined as tools of a particular LLM only. That is what I was saying. You cannot say that Llama 4 supports MCP and Llama 3 doesn't. It is just a tool calling. The client has to appropriately convert the server to the tools. That is what happening here. We are converting the all the routes here with a description. This description will go, this description will go into a particular tool, and then these tools are passed to the LLM. So our application is now ready. Let's test it with few examples. So to run our application, we need to run three servers. The first will be to run our client. Uh, Next, we will run our A2A server. So the A2A server is running on 10,000 port. Let's now also run our MCP server. MCP server is running on 8,000 port. Okay. So let's clear the all outputs here and let's go to the application. This is the application. So currently there are no remote agents present. We have to add a remote agent. Remote agent the A2A server. So we are adding our Linux agent. So when I hit the read, there is a request sent to the A2A server, our Linux A2A server, and all the information for that server is being retrieved. So this is what we have defined in our agent card. Let's save this agent and go to the conversation. Let me clear this code. And now when I hit high, okay, so this is the output, but here you can see neither our MCP server nor our A2A server has been triggered. Only our host replies, hello, how can I assist you today? But now let's ask it a question that will trigger our A2A server. Like list all files on my desktop. Okay, and hit. So this time you can see both A2A as well as MCP has been hit. And let's see whether the output is correct or not. This is my desktop and these are all the files, and this also contains this. So it is running perfectly. Let me also show you that there is a task created and it is marked as completed. The output is this, output returned by the server. Okay, let's now ask a complex query this time. I'm saying in this query, I'm asking to delete a file. I'm not specifying the path or the file name. Let's see what happens. Um, yes, could you please provide me the file path of the agent? So it is now going to the input required. So I have to say key delete ishan2.txt located on my desktop. Stop has been deleted successfully. And here you can see the file is being deleted. So now the file is deleted, and here I have also shown how the input required task status also works. Here you can see the task will be marked as completed, and this marks the end of this video. I hope you have learned about MCP and A2A both. And whenever someone asks, you will say ki A2A and MCP goes together, not it is A2A versus MCP. And like you can differentiate when to use A2A and when to use MCP. So yeah, that's it. Thanks for watching. Please subscribe.